Hey everybody, so in this video we're going to start off by looking at a few sums and differences, just like we were talking about yesterday, 2 with fractions and then 3 with just integers. So if we look at negative 1/5 plus negative 1/5, right, first of all they're fractions, we have common denominators, so we are good to go. So we are just going to evaluate the numerators. So if we do negative 1 plus negative 1, again you can use your addition rules with that, that's just going to give us negative 2. So negative 2 over 5 is our final answer. That can't be simplified, so we are good. All right, how about number 2? So negative 8 minus 4. So the first thing we want to do is our keep, change, opposite. That way we can switch this into an addition problem and use those 2 addition rules. So we are going to keep the negative 8. We are going to change the sign to a plus, and then the opposite of 4 is going to be negative 4. All right, so negative 8 plus negative 4. Both are negative, right? So we have same signs. So that's going to tell us to add the absolute values. So the absolute value of negative 8 is just 8. The absolute value of negative 4 is just positive 4. So 8 plus 4 is going to give us 12. And we keep the sign from the problem. Both of the initial ones from our addition problem were negative. Our answer will be a negative 12. All right, number 3. So 5 1/2 minus negative 1. So if we want to switch this into an addition problem, we can do our little trick, right? Minus minus or minus a negative really is just plus a positive. And you could get that from doing keep, change, opposite as well. I'm going to switch 5 1/2 into a decimal. So 5.5 plus 1. Right? It's an addition problem. Both numbers are positive, so same signs. So we will add the absolute values. So the absolute value of 5.5 is just 5.5, and the absolute value of 1 is just 1. And we're going to make it 1. If we add those up, that will give us a final answer of 6.5. The rule says we keep the sign. Both of them in the addition problem were positive, so we know that the answer is going to be positive. All right, negative 33 plus 77. So it's already an addition problem, which is good. Different signs, right? One is negative and one is positive. So that means we are going to take the absolute values and subtract them. So the absolute value of 77 is just 77 minus the absolute value of negative 33 is actually a positive 33. All right, 7 minus 3 gives us 4, and 7 minus 3 gives us 4 again. So 44, that's a start to our answer, and the sign comes from the number that has the bigger absolute value. So that would be 77, and we know this is positive. So our answer will be a positive 44. All right, number 5, why don't you try that one on your own? We're going to pause the video, and then in a second we'll come back and just do a quick check for understanding. Okay, so hopefully you started by doing your keep, change, opposite. 1 plus negative 7, the signs are different, so we are going to subtract. So we're going to do absolute value of negative 7 is just going to be a positive 7, minus absolute value of 1 is just 1. So our answer is going to be a 6, and we keep the sign, we use the sign from the number with the greater absolute value. So that was our negative 7. So this answer is actually going to be a negative 6. Okay, so again, those 5 problems were just a quick review of what we talked about earlier. Today we're going to step it up a little bit and look at what would happen if we have a problem with 3 integers, right, with a mixture of addition and subtraction. We're going to use a number line to model it, and then we're going to actually do that calculations as well. So first thing, I would say, because again, those addition rules only work if we have addition, obviously. So we need to switch that part of our problem into addition. So if we start off, so negative 2 plus 5, I'm going to keep the negative 2 plus, because that's fine. And then I'm just going to rewrite 5 minus negative 3 in just a different color. So what we need to do is just kind of zoom in on the problem and look at 2 numbers at a time. So if we first started with negative 2 plus 5, that little like zoomed in problem is good because it's already addition. So we're going to zoom into just the red part and do our keep, change, flip. I'm sorry, keep change opposite. So we are going to do keep change opposite. And then we're going to bring the -2 down because that hasn't changed. So now we have a problem strictly with addition, so we can head over to our number line. So we always start at 0. We are going to go to a -2 first of all. So that's the green arrow. Then switch to purple. Then we're going to go +5. So 1, 2, 3, 4, 5. So there's our purple arrow. And then we'll go with light blue to do our +3. And again, we start from the purple arrow. 1, 2, 3. So it looks like our answer for this problem is going to equal 6. Right? So we said when we have smaller numbers, it's nice because we can just use a number line like this. And there's no calculations really that you have to do. You just look to where your last number ended, and that's your answer. But let's just, for the sake of it, let's look at this problem about how we would actually calculate it if we didn't want to use a number line. So we're going to do the same thing. I'm just going to rewrite the problem over here. So -2 plus 5 plus 3. We still need to have the same approach of just looking in at 2 numbers at a time. We already switched the entire problem to addition, which is great. So let's actually start applying those addition rules. So -2 plus 5, those have different signs. So we are going to take the absolute values. So the absolute value of 5 is just 5, minus the absolute value of -2 is just going to be a +2. So 5 minus 2 gives us 3. And we know that, let's see, 5 had the bigger absolute value, and it is positive. So this answer is going to be a +3. So that takes care of the first 2 numbers. We evaluated that, and we know that that's just going to become 3. So then we can bring down this extra 3 at the end that we haven't used yet. 3 plus 3, you know for sure that that is just 6, but we can apply our addition rule again, right? These are the same signs, right? Both positive, so we would just add our absolute value, and that would give us 6, and then we keep the sign. So if we didn't want to use a number line, that is how we could do this by hand with integers. And we can verify, yep, we ended up at the same spot on our number line. So we are good. All right, so we're going to pause the video and get you a chance to try the final example here. So your key takeaway, though, is to make sure you switch this all into addition first. You can model it with your number line, and if you have a couple extra seconds, you can try it with actually calculating it by hand. So we're going to pause the video, give you a second to try it, and then we'll check our work. All right, so everybody, let's check our work. First thing that you would want to do, again, is zoom into your problem and just look at 2 numbers at a time. So 4 minus 8, if we did keep change opposite, we could make that into 4 plus -8. And then 8 plus -2, that was already an addition problem, so we're good. So this is what it would look like if you changed it all to addition. 4 plus -8 plus -2. And if you did your number line and your arrows, you would see that you would end up at a -6. Again, you could have checked this by hand, doing it exactly the same way that we did up here with our addition rules, 2 numbers at a time, and it still hopefully would have gotten you -6. So hopefully this video helped, just a little intro today about what to do if you have more than more than 2 numbers in a sum or difference problem. All right, so thank you for watching, and we're going to get a chance to practice in just a minute.